All right, welcome back, everybody. So for today, we're going to finish notes 2.5. Now, remember, we already talked about squares, right? Perfect squares. Here's our list. It comes from our word wall. We talked about how we reduce our radicals if needed. We can use the old-fashioned tree method, but of course, we're trying to stay away from that, and we're trying to use our very quick method to do that instead. Of course, we also discussed in our notes, we talked about how you can solve quadratics by using factoring, which we will continue to do today as well. We also talked about how you can use square roots. Remember, there was a difference when you're dealing with standard form, meaning we have two x's in our quadratic. That's when factoring kicks in. And of course, when you only have one x with a power of two, we're dealing with vertex form, but that means we get to use the square root technique. So yesterday you had this one as a U try, but just as a reminder, look, we would add the 8 to both sides. The idea is you cannot bring in the square root too early. 56 plus 8 is 64. Now that the power of 2, right, the x with the power of 2 is by itself, that's when we can bring in square roots on both sides. And of course, we're supposed to get two answers. So that's why the very first thing I do, I don't worry about this. I worry about writing plus or minus because we are guaranteed to have two answers. So the plus or minus is needed. And of course, the square root of 64 is 8. The whole point of taking a square root is that the number comes out of the box, right? The radical. So that's why my two answers are x is equal to 8 and x is equal to negative 8. So let's talk about a couple more complicated problems in this. If you notice, yes, this is vertex form, but it literally just said x squared. There was no number on the inside. So let's look at the last page we need to talk about for today in this section, of course. And that is, well, look at it carefully here. We're talking about square root. So now notice, it has one x with a power of 2. This is starting to look a little bit more like vertex form. But we're worried about solving. Remember, we're still looking for x-intercepts, solutions, roots, whatever we want to call it. The rule is, yes, I'm going to need a square root to get rid of this power of 2, but we can't yet. First thing I need to do is just like anything else, I need to get rid of the 5. So I'm going to add 5 to both sides. So then 2x plus 2 squared is equal to 14. Now, the question is, now can I bring in square roots? Well, the answer is no. Can't bring in a square root yet. So, since we can't get a square root yet, see, here's the thing. This is what has the power of 2. It's not by itself yet. So we have to get rid of the 2. They're right next to each other. And no, I'm not going to distribute. I'm not allowed to because of the power, but I can get rid of it with division. So I'm left with x plus 2 squared is equal to 7. But the idea right from the beginning was I can't bring a radical 2 into the mix until this is completely by itself. Well, now it is. And now that it is completely by itself, here comes the square root on both sides. The power of 2 and the radical will cancel each other out. But this time, instead of just x, I'm actually left with x plus 2. First thing I do on this side, though, I don't care about that 7 yet. I have to say plus or minus. Now I can bring in the radical 7. Since I can't reduce it, I just leave it in there. And finally, we do have two possible answers, but the x isn't by itself. So I'm going to subtract the 2 from both sides. And just like that, look, the x is by itself. Now, remember, there's a plus and a minus. We usually like to leave that in the center. So I'm going to write the negative 2 and then the plus or minus radical 7. Just remember, we needed to get two answers. We needed two x-intercepts. So here are the two answers. X is equal to negative 2 plus radical 7. And of course, x is equal to negative 2 minus radical 7. Those are the two x-intercepts. Even though they look kind of weird, I would turn them into decimals if I needed to graph them. But those are my solutions, my x-intercepts, my roots, whatever we want to call them. Those are right there. But again, it's the idea that we need to get the power of 2, whatever has a power of 2, all by itself. Now, look at the next one. Here is what has the power of 2. And you have to ask yourself, am I ready to bring in a square root? The answer is no. Clearly, we have to get rid of that 40. So let's add the 40 to the other side. All right, now this one only took one step to get it all by itself. But you see now, whatever I had in orange is officially, and it equals 49. This is now officially by itself. And so because it's by itself, there's nothing behind it, there's nothing in front of it. Now I can bring square roots into the mix. And when I bring in the square root, well, yes, this goes away. Power 2 and a radical cancel, leaving me with p minus 4. Don't worry about this yet. If you're already thinking about, oh, it's 7, you're doing it wrong. Remember, you have to have two answers. You have to bring in the plus or minus. And then the square root of 49, well, that's just 7. So there's a 7. Now, last time, that 7 was stuck in a radical. So I didn't worry about it because I couldn't do anything with it. But this one, there is no radical. So this is where I like to do my split. I like to split my problem up into two. So we're going to do the split. And the first one is p minus 4 is equal to 7. The other one is p minus 4 is equal to negative 7. Remember, these are regular numbers that I have to work with. So that's why I have to take this little step so that I can actually finish the problem. So we add 4 to both sides. And just like that, we have our two solutions. P is equal to 11 and p is equal to negative 3. These are my roots of the quadratic. You might call them x-intercepts. Actually, I would have to call them p-intercepts because that's the letter they're using. But it's the same concept. We're still just solving a quadratic and looking for where it would cross the x-axis or the p-axis, even if they change the name. Now, I know it says U-try, but this is kind of new for us. You'll have your own U-tries coming up shortly anyways. So let's keep it going here. So let's look at U-try number 1. Again, you have to ask yourself, am I ready to bring in a square root? Again, we're not. See, looking at this problem very carefully, we still have that negative 2 out in front. And no, we're not allowed to distribute because of the power of 2. That's not allowed. But I can definitely get rid of it. So dividing by the negative 2 as mentioned. Negative 2 is gone. And yes, look at this. We have the x plus 3 to the power of 2 all by itself. Negative 18, negative 2 is positive 9. But see, now it's on its own. Now I can bring in the radical. Never bring in the radical too early. Never. So then I end up with x plus 3 is equal to, and again, I don't worry about this. I need to get that plus or minus going. Square root of 9 is just a 3. And because this is a nice number, not a radical 7 like it was up there, then I am going to do my split here. I'm going to go x plus 3 is equal to 3. X plus 3 is equal to negative 3. And a little bit of solving here. Subtract the 3 from all of them. And so we get our first x-intercept is 0. And yes, that's okay. 0 counts as a number. And of course here, they don't cancel, but I do end up with a negative 6. So again, when you're working with these problems, don't bring the radical in too early. The power of 2, anything that has the power of 2 needs to be by itself. So with this last U-try here, again, I like highlighting it. It reminds me, here's what has the power of 2. Don't accidentally highlight that 3 though. The 4 has no power of 2. The 3 doesn't have it, but according to what we do with solving, I would have to get rid of this number first. So I'm going to add the 4 to both sides. There's the x minus 1 to the power of 2 is equal to 9. But again, this is not by itself. We still have that 3 out there. And no, we can't distribute the 3. We're not allowed to. But I can definitely get rid of it with a little bit of division. That's how we always get rid of numbers next to something. They're multiplying anyway, so we use division to get rid of it. So now the x minus 1 quantity squared is finally by itself. 9 divided by 3 is 3. And so we are now officially ready for the square root again. Never bring it in too early. So we're left with x minus 1 is equal to plus or minus. And now, can we take the square root of 3? Not at all. Then leave it inside the radical. This is one of the only times you leave it in there. Over here, the square root of 9 was a 3. There should be no more radical left. Here we do. And because it's a radical, I'm not going to be able to do much with it. That's why here, we don't really need a split. You could split it too if you wanted to, but I might as well move it over now. And then look, here's my answer. X is equal to a positive 1 plus or minus. We like to kind of keep those in the center there. Radical 3. And yes, we should split our answers. I believe BIM wants you to split your answer. So x is equal to 1 plus radical 3, and x is equal to 1 minus radical 3. Those would be the two solutions that we would type in as a result. Just remember, take a moment to catch up with the writing if you need it. So leave it here for a little bit longer. But the idea is make sure that whoever has the power of 2 is completely isolated before you even think about bringing in radicals. And of course, remember, we did that over here too. I didn't bring the radical in right away. I made sure that whoever had the power of 2 was by itself first. Then the radical comes in. We did that for all of these. We had to get the x squared by itself. Well, here we have to get the power of 2 of whoever has it completely on its own. So then that brings us to the last two problems that we're going to talk about. And yes, they are on the test, so we want to make sure that we're ready for it. Okay. All right. That's a little better now. Okay, so a skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. All right. Now notice, when they say altitude, they're letting me know that's the original height that someone dropped from. But that's the original height. I'm going to put OG so I don't forget. Then it says, use this formula. Okay, they gave me a formula here to write an equation that gives a skydiver's height. So H is your height in feet during a free fall of T seconds. So T is definitely time after a skydiver drops out of the airplane. Okay, so again, look, use the formula to write an equation that gives the skydiver's height in feet during free fall. Well, they already wrote a formula for me. So that's the interesting part here. They already wrote it. Well, then, here's the only thing I can plug in. I don't know what the height is. This one keeps changing. As the skydiver is dropping, that height keeps changing. We don't know the time, so we're going to leave the letter T alone. But H sub 0. Now, in some of your classes, you may have seen that before, but H sub 0 stands for original. And if we knew the original height, we do, it's up there, then we can plug it in. So H sub 0 means the original of something, right? The initial, the start. So they started at 4,624. Well, there it is. They wanted me to create an equation. Well, we've got one. They had already done it for me. All I had to do was just plug in a number right there. So then let's see if B is actually something a little bit better. Is it possible for the skydiver to wait 18 seconds before pulling the parachute cord and then explain? Well, what stands out to me is the fact that they gave me a number. So they said, can the skydiver wait 18 seconds before pulling the cord so that the parachute opens up? Okay, well, if it says 18 seconds, well, think about it. That's not a height. It says seconds. T is seconds. Then they're giving me a letter T. And if they're giving you a value and they said, well, do something mathematical with this, well, if they're letting you know what T is, well, just plug it in. All right, again, we had a formula. So here it is. H is equal to negative 16 T squared plus 4,624. Obviously, I didn't write the letter T because they already told you what it is. So we're going to plug it in and we're going to find out what the height is when 18 seconds hits. Okay. And we're going to see if the skydiver should pull the cord at 18 seconds after waiting 18 seconds. So let's do the work here. Of course, we're going to let Desmos do all of this work here for us. Everything here, we're going to type it into Desmos exactly the way we see it, with the negative, with the 18 in there in parentheses. And Desmos is going to say that the height at 18 seconds is negative 560 feet. And remember, this is at 18 seconds. That's the height at 18 seconds. So think about that number for a moment. Okay, think about the situation at hand. Skydiver's dropping from the airplane. This is the height, right? Positive 4,624. They said, can he wait at 18 until 18 seconds and then pull a cord so that the parachute opens? Well, if it's negative 560 feet, that just means one thing. He's already hit the ground a while ago. I mean, negative 560, that means he's already underground. So the answer is no, right? No. He would have already hit the ground at 18 seconds. Remember, we have to be specific. So they said, can he wait to pull the cord until he gets to 18 seconds? Yeah, that's probably not a good idea. He's going to hit the ground at that point. So there we go. But you see, that's the thing. When they give me a formula, all we do is plug in. They gave you a formula. So watch. Here we have another uh, similar problem. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 80 feet. All right, so when you drop it from 80, we don't want to make sure the egg doesn't crack. When the object is dropped, its height h in feet above the ground after t seconds, so they're letting me know what the letters represent, can be modeled by this equation. Well, look, they already put the 80 in there for me, so I don't have to worry about the 80. It's already done. So now the question is, how long does it take the container to actually hit the ground? All right, so again, we have an equation. Let me write it down. There's two letters in this equation. And if you think about it, listen to the question. How long does it take? That's what they're asking me right there. Well, there's two letters. There's an H and a T. That's how we break down word problems. There's an H and a T. If they want to know how long it takes, well, not that can't be H for height. They want to know a time in seconds. So that's what they're doing. They want to find what time it is. That's the question being asked. So I don't know what T is. So I can already start writing this out. Negative 16T squared plus 80. But I can't write H. You see, if they want me to solve for the letter T, they have to tell me what the height is. And the mistake people make is they go, oh, it's 80. Now remember, they already wrote 80 here. I can't write 80 twice. But they do mention one thing, and sometimes we read it over and over and we still don't see it. You have to remember, they dropped it from 80. And then they said, so that's the height, right? To the ground. Well, it already hit the ground. So if it hit the ground, then what would be its height? Well, from here to here, it's 80. But if you already hit the ground, then we're talking about 0. You already hit the ground. There is no height. So my height is 0 because I hit the ground. My height has to be 0. And now I'm ready to solve. Now it looks like the problems we did earlier. So if I'm going to solve something that has a power of 2, I can either factor, but this one doesn't have an extra t, or I can use square roots. Now, is this thing ready for square roots? Not at all. This is what has the power of 2. It is not by itself. So then we subtract the 80. So now it says negative 80 is equal to negative 16t squared. So now, can I bring in square roots? No. This is what has the power 2. The 16 doesn't have power 2. It's not in a parentheses with it. Then the 16 shouldn't be there either. You have to get rid of that negative 16. And division is the only way to go with a problem like this. See, everything's gone now. And finally, the t squared is by itself. That's what we've been wanting this whole time. That's what we did on the other side of the paper. And so now negative 80 divided by negative 16 is 5, a positive 5. So Now, can I bring square roots? Absolutely. We're going to bring in a square root on both sides. And yes, technically, I'm supposed to say t is equal to plus or minus. Can I take the square root of 5? No. Then I'll leave it alone, which means those are my two answers. Now, this is kind of tough to understand if you tell somebody, oh, yeah, it's going to take radical 5 seconds. What's that, right? So this is a good time to turn something like this into a radical with your into a decimal with your calculator. And using your calculator, it turns out that it's about 2.2 seconds. But I have a positive and a negative, right? Technically. But if you think about the problem, they said, how long is it going to take for it to hit the ground? Then here's my answer. It will take 2.2 seconds to hit the ground. Notice I didn't say plus or minus because a negative doesn't make any sense. This is my answer. I go with only the positive time. I don't have a time machine. I'm not going backwards. A negative wouldn't make any sense here in the context of the problem. Only the positive would. So there you go, everybody. These one of these two questions will end up being on your next test at some point. I do believe you have one like that in your BIM for tonight, so just be ready for it. But there it is. This is it for this section. You do have this page where you're going to practice a little bit of everything that we did. So this is your you-dos, basically. So you should go to page 20 and work on these 4 problems. Don't forget to check your answers on the whiteboard there. Go check them once you're done. And if you are done, then go on to today's BIM. Just make sure all your BIMs are done. It's a great day to catch up on any missing work. All right, with that said, have a wonderful day, and then I'll see you soon this Friday. All right, have a good day, everybody.